Hi, my name is Stephen Yatco. I'm a manufacturing engineering major at Cal Poly, and for my senior project, I worked with WASCO Incorporated to test their pressure and vacuum switches under different conditions suitable to a semiconductor application. And here on this slide, you can see the S-spec environmental chamber that I'll be working with in my project. WASCO Incorporated began as a screw company by the Way family. The name WASCO is a combination of the words Way Screw Company. The Ways still own WASCO today, and I've had the privilege of working for them this past summer as an engineering intern. They manufacture pressure and vacuum switches, along with pressure transducers and transmitters. These devices are used in many applications under the hood, including semiconductor, fire suppression, automotive, medical, industrial, defense, alternative energy, and process control markets. Basically, how they work is they all have a diaphragm that expands or contracts under pressure or vacuum. When it reaches a set pressure, the diaphragm triggers a micro switch that then sends a signal to whatever system an industry has set up. Lam Research is a wafer fabrication company that supplies its equipment and services to the global semiconductor industry. The purpose of this project is to satisfy Lam's requirements for the specific products that WASCO has been developing for them. Their switches must be pristine in terms of cleanliness, surface finish, and absence of contaminants in the product. Also, these switches will be subject to different environmental conditions, which is why they must be tested. WASCO's environmental chamber is an S-spec Platinus series reach-in variety, which will allow us to reach temperatures from negative 80 to 120 degrees centigrade, and also vary humidity simultaneously. Depending on the switch, we will need to have a different program set up for the machine. This is a picture of a general example of what pressure and vacuum switches manufactured by WASCO look like. But these are not the ones that they're developing for Lam Research. Here's the problem. By January 2015, WASCO needs a method to test 50 to 100 switches under specific stringent environmental conditions designated by Lam Research. I will go over the deliverables for this problem solution in the next slide. Throughout my internship with WASCO, I picked up on a few of their problem-solving strategies that I will combine with those that I've learned in school. Learn as much as possible before beginning. Setting up an IKEA desk may not require extensive instructions or prior research, but research is very important for big projects, especially when a mistake could be costly in terms of safety and finance. The department at WASCO, including myself, has been through on-site training for the programming language that we will be using in the environmental chamber. I have also completed a literature review of 10 sources that will help me as I work through this project. The next is crawl, walk, run. Crawl, walk, run is a saying that WASCO Research and Development Department lives by. For any project like this, we must begin with drawings and ideologies before moving on to prototyping, testing, and producing the final product. One thing I've learned the hard way is rushing through something does not usually yield the desired results. Trust but verify. It is good to get different perspectives on a problem to help you generate your own way of looking at it. In general, trust what your colleagues say, but be sure to look it up for yourself. That way you have more than one source of a solution and will most likely work out. PDCA stands for Plan, Do, Check, Act, another project management method that I've learned at Cal Poly while studying in their industrial and manufacturing engineering department. This goes along with learning as much as possible in the beginning, but also planning for the future. In 2 slides, I'll explain a Gantt chart that shows past and upcoming goals for my senior project. SMART stands for goals that are specific, measurable, attainable, relevant, and time-specific. A Gantt chart also helps with this. The group of engineers who I'm working with are good at sharing and explaining their SMART goals with me so that I know exactly what must be done to achieve them and to verify that the goals have been achieved. The picture on the right is the inside of the environmental chamber. On the bottom of the chamber and the back is where the humidity is generated. On the top, there's a fan to help with circulation, as well as 2 thermometers, one wet and one dry, to keep track of the relative humidity within the chamber. Deliverables for this project include designing a program with LabVIEW that will allow users to easily test parts incorporating poka-yoke or error-proofing. We want to be able to test switches by cycling pressure under different temperatures and humidities. This objective includes designing a program or process that is able to detect the failure of a part and allows little room for the operator to make a mistake. The next objective is to design and manufacture a manifold to hold 50 to 100 parts without damaging or introducing contamination to them. I have more experience with this from my last project at WASCO because I did a lot of work with a Haas VF2 CNC mill, Autodesk Inventor HSM, which is the integrated CAM software for Inventor. Below you can see our test program that we created with LabVIEW. This program confirmed our method of communicating with the SPEC environmental chamber. We connected to the chamber to WASCO's network, and we were able to give it commands and receive responses using the TCP method of transmitting data back and forth. Here's a Gantt chart of the general goals so far. Green designates completed tasks, while those in red are yet to be completed. Although goals like program HMI and design manifold are planned out specifically, the reality is we are working on both of those goals at the same time. So far, we've had a week of LabVIEW training where a representative of National Instruments came to our facility from Texas and trained us in person for a week. Also, an SPEC representative came on site to train us on the operation and maintenance of the chamber, and also to check to see if there were any malfunctions in the chamber. Currently, we're working on programming the HMI with LabVIEW and getting ideas for prototypes of the manifold. I will continue to update this chart as new objectives come up. These are the IME principles that will be covered in this project: quality, design of experiments, data management, metrology, CAD/CAM, and automation. I would say that there's an equal amount of relevant information that I've learned in school and information that I've learned by working at WASCO since the beginning of this past summer that will be very useful for setting up the chamber. The pictures on the right is our potential device that will be used for our prototyped manifold. We found this device in a tub of scrap that we bought for cheap off of another company who wanted to get rid of it. A lever controls the top level that can be raised and lowered and locked at both positions. The left picture shows the tray lowered and the right picture shows it raised all the way. There are 2 cylinders lined with ball bearings to slide up and down on each shaft to make for a smooth motion. Our thoughts are to modify this contraption to fit at least 20 switches and be able to test it in the chamber as a prototype. We've done a lot of training and research so far, and I'm sure there's much more to be learned as the project progresses. I'm excited to be working with such a brilliant and friendly staff at WASCO, and also to finish my time at Cal Poly with a great achievement under my belt. Thank you for watching.